This conference will now be recorded.
Hi, good morning. Today's session we're going to discuss about the dynamic tables features. What are the limitations and what are the features dynamic tables has? Okay. Now, after that, I'm going to create the one dynamic table using the concept called CDC, Change Data Capture. Okay. Now we'll see the features one by one. The first feature I'm going to say cost for dynamic tables. Okay, what are the costs will be involved when you creating a dynamic tables? For creating it won't incur any cost. Okay, for incremental refresh, they have incur additional cost. Now, I'll say what are the things will compute the cost. Okay, first one is compute cost. Mostly, you'll use dynamic tables to do the continuous data transformation. For continuous data transformation, you use dynamic tables. This dynamic tables require virtual warehouses. If you use large warehouse, right, what will happens? The large warehouse will have more memory. It will run your data transformation very faster. Dynamic table requires virtual warehouses. The virtual warehouse only it will refresh your datas. Whenever the data comes in the source table, if any updates or inserts or new records comes in the source table, it will refresh. The new records will be refreshed and put into the target table as per the query given by the dynamic tables. Okay. Now this virtual warehouse is going to refresh your data, as well as this virtual warehouse not only going to refresh, it's going to run queries. What are the queries you have provided in the dynamic table? It's going to run your queries. Okay, it's going to run your queries and then going to refresh the data from the source table. As well as it can be done in two ways. One is scheduled way, another one is manual refreshes. Mostly the dynamic tables will go for the auto refresh. Whenever the new data comes into the base table, source table or base table, it automatically refresh. Okay, as per the query given by the dynamic tables, it's going to do the transformations. Now, what happens? Dynamic tables using one service called cloud service compute. Cloud service compute. What this cloud service compute will do, right? It will identify the changes in the underlying source table. If any updates or inserts or deletes happen, this cloud service compute will identify those changes. For identifying those changes, what happens? It some credits will be involved in the Snowflake. What I'm saying is, if any changes happen in the source table, we have to identify those changes. For identifying those changes, using one service called cloud service compute. Okay, and then this cloud service compute will track those changes. And then virtual service, what happens, right? If there is no data in the source table, no cost will be involved. Okay, what I'm saying is, if there is no data in the source table, there's no updates, frequent updates, or deletes, or inserts happen in the source table, the virtual warehouse credits are not consumed, since there are no new data to refresh. In source table, if you have no new data, no inserts, update, deletes happen, then virtual warehouse credits are not consumed. When it will consume, right, if any data comes into source table, then new data comes into source table, this cloud service compute will identify the changes, and then it will inform to the virtual warehouse. That virtual warehouse, what will do, right, it will extract the new data and will apply the transformation and put into the materialized result as in the dynamic tables. Okay, that's what I am keep on saying to you guys. If there is no changes, no credits are consumed. If any new data happens, right, the service compute will handle the changes, and then your virtual warehouse will take the delta part and then do the transformation and finally put into the materialized result in your dynamic tables. Okay, and second point you have to keep in mind: if your virtual warehouse suspended. If your virtual warehouse suspended, and then you have to think in mind, if a virtual warehouse is suspended and no changes in the base object, in source table there is no changes, the suspended warehouse will not invoke and no credits were consumed. Satish, scenario number 2, virtual warehouse suspended. In source table, what happens, right? Source table, what happens? No changes in the base object are identified because your virtual warehouse is suspended. If virtual warehouse is enabled only, then only this cloud service compute will detect those changes. If your virtual is suspended, it can't able to see the changes in the base objects. Okay, then what happens, right? The suspended virtual warehouse cannot get invoked and no credits were consumed. Okay, and then what I'm saying to you, saying here is, if any virtual warehouse in suspended, then no credits were consumed. Okay, and then in case another scenario, if changes were identified, what will happen, right? The virtual warehouse will be automatically resumed to process updates, because whenever there is no updates, right, your virtual warehouse will go to suspend state. Virtual warehouse will go to the suspend state. Okay, and then suddenly in source table I'm getting 3 inserts, 2 deletes, and then 1 update. What will happen? Your virtual warehouse, it will go from suspend state to
Active.
active state or resume state. Okay, we will go to resume state and then we'll process updates. That's what I keep in mind. If there is no updates or deletes or inserts in the source table, it will go to suspend state and no changes in the base objects were identified. And then what happens, right? There won't be any credits will be consumed. And then if any changes are identified, virtual warehouse is automatically resumed to the process updates. Okay, and then I want to show this thing. Third point: if I given the target lag as 5 hours, my credits will be consumed less. If my target lag is giving 5 minutes, what happened to the compute cost? Scenario number
Increase.
1, target lag are giving like 5 hours. The credits consumed is very less. If I give the target lag is equal to 5 minutes, what happened to the compute cost?
Sir, it will increase, sir.
It will increase. That's what I mentioned here is, whenever you're giving target lag, okay, just give some, what I'm saying is, give the lower target value. Lower target value means like, what I'm saying is give like 5 hours or 6 hours. Okay, after 5 hours, what happens is it will refresh. Now, if you give low target value, right, 2 minutes or 3 minutes, what will happen, right? What will happen if you give low target value? It will refresh every 2 minutes or every 5 minutes, and then they will incur higher compute cost. Sendamal, if you are giving the low target value, what will happen? The refresh will happen more, and then they will incur higher
Compute cost, sir.
higher
Higher cost, sir.
compute cost.
Cost. Compute.
Compute means like doing some transformations, right? You're doing some computing, all kind of transformations. It will more cost will be there. That's what these 3 things you have to keep in mind. Okay, this cloud service compute will align with these changes, and then what happens, right? And then based on this cloud service compute thing, virtual warehouse will be invoked. Okay, if there's no changes in the source table, what happened, right? Your virtual warehouse will still remain suspend state. If any changes happen in source table, this cloud service compute will identify the changes and inform to the virtual warehouse. Virtual warehouse will come to the suspend state to resume state, and then it will extract those delta, and then it will do the transformations. And then third thing is, you have to give the higher target lag. If you give low target lag, right, it will do the refresh continuously. It will going to incur higher cost. And then these operations, you know, right, how to do the monitoring. Go to the monitor session and see the data tables. Okay, you can see how much it refresh, The last two sessions I've shown all these things to you guys. You have to go to the monitoring menu and then you have to see dynamic tables. You can see like how much it's data it's got refresh, how many times it refresh, everything can able to see. Okay, I'm going to show this part later now, and then now we'll go to the limitations. Yeah, I think there is one more topic is there. One second, guys. Understanding cost. Yeah, I want to discuss few things about storage cost. Uh, Whenever you think about storage cost, you have to think in all these considerations for dynamic tables. Okay, because dynamic tables require storage to store the material results. Now, can anyone say what is materialization? Anyone can say what is mean by materialization?
Physical snapshot of table.
Physical started table. No. Sendaman and Sadish, what is materialization? What is materialization?
This conference will now be recorded.
Guys, first we want to discuss about the materialized results. Materialized results means you have to collect the results from various tables and then you have to store in one physical location. Okay, this materialized table have a physical table. Okay, it have own storage space. That's what dynamic tables require storage to store the materialized results. Okay, dynamic tables will have a physical location. Okay, and then similar to regular tables, dynamic tables also will incur additional cost for time travel, for fail-safe storage, and cloning feature. Now we're going to discuss one by one. These are the various considerations for dynamic tables. These are the things will incur additional cost for dynamic tables. Now, first one we're going to see about the time travel and fail-safe storage. Time travel is nothing but if I accidentally deleted few records or deleted some few records from the table, you can go to that previous days and get those records. For example, for dynamic table, the time travel I given as 7 days. The default is 7 days. You can keep 7 days, 10 days, 14 days, but defaultly it will be 7 days. If I accidentally deleted 5 days before 3 or 4 records, now if I want to recover those records, I can use a time travel feature. I can go to that corresponding date and time and can retrieve those records. That's a time travel feature. If you are using time travel feature, what will happen, right? In dynamic tables, they will incur additional credits in the Snowflake. Now, time travel feature used to access the historical version of the dynamic tables at specific point of time. Because in a table you have history of records. I want to go to specific time and then I want to extract what are the records I have accidentally deleted. Okay, and then yeah, I need some set of records from my previous days. I can able to extract it using this time travel feature. I kept some points over here. Yeah, a little bit hints about time travel. Okay, I can able to restore the data and objects. I can able to recover the tables, schemas, and database that might have been accidentally or intentionally deleted. If you're deleting the tables or deleting schemas or deleting database, you can able to recover it, and then you can able to duplicate and backing up your data from key points in the past. Though you have historical records, I want to duplicate some records, I want to back up some data, I can able to do it within time travel. And then third thing is, if I want to do some manipulation, I want to analyze some data for specific period of time. For example, today is Wednesday. I want to take Sunday's data. I want to do some analysis. I can able to get it. I want to give the timestamp. I can able to extract the data. That's a time travel feature. If we enabling the time travel feature, what will happen, right? That going to additionally incur the cost. Second one is fail safe. Fail safe is nothing but, for example, after 7 days, after 7 days, you can't able to recover your deleted data because The default time travel days, how many days? The
7 days.
default 7 days. If you exceeded 7 days, you can't able to recover the data loss or corruption. Okay, what you have to do is you have to mention the fail safe period. Okay, so fail safe date you can use, what you can do. Otherwise, if you're not specifying the fail safe feature, you can contact support team and then you can get those data. If you are enabling the fail safe feature, what will happen? That also going to incur additional cost. Okay, see, in time travel feature itself, you can able to get the data. If you are exceeded more than 7 days, right, you can't able to get the data. At the time, you have to contact support team, and then if you have enabled the fail feature, like you can able to record the 90 days data also. Okay, you can able to recover it. That is a fail safe feature. You should protect data tables from data corruption. Okay, and then second thing I can say, like for example, your data center going down. Okay, due to some disaster is going down, and then suddenly you lost your data, but you have the fail-safe feature enabled for your data tables. You can able to contact support team, and then you can able to recover it back. Okay, and then second point is replication. You can able to enable the replication feature in data tables. Replication nothing but you can keep your data in cross accounts. Cross accounts means I hosted my account in Virginia. I can keep in the Singapore account as well, and cross region replication as well. From one region to another region, I can have the data. Same data can have the backup. It's kind of replication. What are the data I have in the current region, right? The same data can be have in another region. Okay, and then if you are keeping a replication, right, what you can do, you can able to copy data from primary database to secondary database if any disaster recovery for either disaster recovery. For example, I hosted in Virginia region. I have the data in the Virginia region. Due to some disaster, I lost my data, but I have enabled the replication. What I can do is just I can replicate those data, whichever I replicate to the other regions, right? I can able to replicate those data. I can copy the data from that primary to second database, as well as using data sharing also I can able to share the data. Okay, these are the features that will incur additional cost. If you are using replication, that's going to be incur additional cost. And then one thing I want to share here is data sharing. Data sharing means you can share your data from one account to another account. It can be cross accounts. Cross account means my account to Satish account I can able to transfer the data. Transfer means I'm not going to move the data. I can give the access to my database. Satish can able to see my data. That's called data sharing. Okay, it's only read only purpose. It's only read only purpose. In Redshift as well as in Snowflake, they have this feature called data sharing. If you want to access your database, if you want to provide access to database, you can give access. The other peoples can able to see your data. It's their read only purposes. And then mostly if you use replication data tables, it's going to incur additional cost for replication cost. How much you're replicating to other cross regions, that you have to pay for that. Okay, and then next feature is suspend data tables. If you are suspending data tables, it's not going to incur any additional cost. Satish, if I suspending my data tables, whether the data tables will get any updates?
No, sir.
It won't get any updates. It won't refresh actually. Okay, because you are suspending the data tables. If you are resuming the tables, what will happen, right? It will refresh those base tables and get the data. Okay, if you are suspending data tables, what happens? There won't be any additional cost beyond the storage fees, because every data table has storage, right? It has a physical location. You have to pay for storage location, but it's not going to additional cost is not be involved, because your data table is
Suspended.
suspended, and then it is not going to compute the, it's not going to consume compute resources, because in data tables You will provide the query. It's not going to do any transformation. It's not going to consume any compute resources as well. Okay. If you are going for any maintenance, okay, or scheduled jobs, what you can do, right? At that time, you have to make your dynamic tables in the suspended state. Sendamal, when you have to make your dynamic table suspended, if you are going for ongoing maintenance, ongoing maintenance, at the time you have to suspend all your jobs. Okay, at the time you have to suspend your task. At the time they won't be incur additional cost. But what happened, right? For storage, you have to pay for it because every dynamic tables will have your physical storage location. Okay. Now, next one is transient dynamic tables. Already said to you, transient dynamic tables, there won't be any fail-safe. There won't be any fail-safe. And then, if any disaster recovery happens, if any disaster happens, you can't able to record the data because fail-safe will not be enabled in transient
Transient
table.
table.
If any disaster happens, what will happens, right? The entire data will be lost or corrupted. Anything happens, you can't able to record the data. Okay, and then transient table similar like physical table. Okay, until you're dropping, it will persist in the uh, tables itself. In the database itself. Until you are dropping, it will be still in the database itself. The only drawback is you does not have fail safe. Okay, that's another first point. Second point is the transient tables mostly used for if you are doing some intermediate transformations like kind of temporary tables, you can use transient. That's why use of transient tables. If you are doing some intermediate transformations, you want to store those results in the intermediate layer, you can use transient tables. Okay, now you can create transient dynamic tables mostly used for keeping your transitory data. Transitory means you can keep all kind of temporal transfer data. Okay, and then I already said, right, it's have the same level of data protection and recovery product permanent tables. Okay, you can do like time travel, you can do all things, but fail safe you will not be able to do. Okay, that's the drawback of dynamic tables. The transient dynamic tables also will go into additional incurred cost. And then additional storage for increment refresh operations. Now, you might think for increment refresh, why they are charging additional storage? See, I'm not going to talk about cost. I'm going to talk about the additional storage. You might think, wondering, why this additional storage is required? In dynamic tables, what happens, right? It's going to maintain a internal metadata column. Sendamal, the dynamic tables is going to internally maintain a which column? Metadata column. Okay, this metadata column will be able to identify each row within the table. You might think which row are you talking about? In a table, I have 1,000 records. 1,000 records. The 1,000 records index value will be stored in which column? Internal
Metadata.
metadata column. Okay, see, for example, if I want to go to Sendamal house, I want to know the Sendamal address. If I want to go to Satish house, I want to know the Satish address. Like that, in dynamic tables I have 1,000 records. 1,000 records, what happens, right? That address should be known. What is happening, right? This internal metadata column is having the internal row identifiers. Based on the internal row identifier, then only you can able to access or identify the each row within a table. This internal row identifiers consumes a constant amount of storage. Okay, for example, I want to store the Snendam address in my brain. Okay, Satish address in brain. It needs some storage space, right? The same thing, the metadata column, we need here some storage per row. If you are storing all these internal row identifiers, that going to increase the storage cost. For example, if you want to store 1 million records, 1 million raw entry values you have to store in that metadata column. That's why additional storage cost involved in dynamic tables. Satish, now 100 records is in the dynamic tables. In stores table, 50 tables were newly identified and got refreshed. Now, what is the total records in the dynamic table?
Sir, 150, sir.
150 records. Now, this internal metadata column has to maintain 150 row identifiers. That 150 row identifiers, it's going to consume a constant amount of storage space. That's why they're saying how if you are increasing the records, right, like millions or millions or billions of records, the storage cost will be involved in this dynamic tables. Now, last point I want to show here is refresh schedule cost. There are two kinds of refresh are there, okay, in dynamic tables. One is full refresh, another one is incremental refresh. Now, if you are going for a full refresh, what will happen, right? It has to refresh the entire table and then has to put in dynamic table. Incremental means whichever data got changed or based on the DML operations inserted or updated, that records alone will be refreshed and put into the dynamic tables. Okay. Now, whenever you are doing some refresh, right, you have to choose which refresh mode you have to go for. Mostly dynamic tables you go for incremental refresh. Depends on the use case. Okay. If you are going for incremental refresh, right, what happens? It will going to reduce your cost because you are not going to transfer huge amount of data to dynamic tables. Only a delta part you're going to transfer. There won't be a less IO will be there. It will be reduce your cost. Now, you have to decide which refreshing factor you have to choose. One is full refresh schedule or incremental refresh schedule. Okay. What happens? Now we're going to talk about the full refresh schedule. Okay. Now, in full refresh schedule, what they're saying is suspend your dynamic tables outside of business hours. Satish knows this particular time only I want to do the refresh. During night hours, I should not refresh. Okay, if you have given dynamic tables, right, what will happen? Every 5 minutes or every 10 minutes, it keep on refreshing those source tables. That should not happen. What they're saying is to reduce the cost, suspend the dynamic tables outside of business hours. Okay, uh, and then the full refresh I already said to you, right? It's going to take all the data and going to put into the dynamic tables, and then they are asking to set the refresh frequency. Don't keep for lower lag time. Keep some higher lag time, like 5 or 6 hours. Okay, that will reduce the cost. And then if refresh is not required, what happened, right? Suspended dynamic tables outside of business hours. Okay, only which time it required, that time alone you can able to refresh. And then if dynamic refresh is not required, go for manual refresh. Okay, that thing also possible. Now, incremental refresh is there. Incremental refresh is nothing but what happens, right? Only a delta part will be extracted, and then it put in dynamic tables. It reduced your overhead. If you are doing full refresh, right, what happens if you have millions of records that will be transferred to dynamic tables? If some connectivity issues there, some exception has occurred, right, the entire data will be lost. Okay, the delta what will happen, right? Whenever the new data comes in, it will going to refresh every 5 seconds or 5 minutes. It's going to put into the dynamic table, and then they're saying like that. Just what they're saying is just go for high refresh frequency rate. That will going to reduce your cost. You can set your high frequency refresh rate to reduce your cost. This is what they're saying is. Now go to the limitations. What are the limitations we have in dynamic tables? The first limitation I'm going to discuss is a single account can hold a maximum of 4,000 dynamic tables. Satish is owning an account. Maximum how many Dyna tables you can create?
4,000.
4,000.
4,000 Dyna tables only you can able to create. Okay, if you can't exceed more than 5,000, 4,000 Dyna tables. If you want to exceed more than 4,000 Dyna tables, you have to contact the support team. Okay, you have to contact support team. But as per the default properties, only 4,000 Dyna tables will be created. Second point is you can't query more than 100 tables. Satish, I already discussed with you. Whenever, yeah, I can show this diagram to you guys. Yeah, you can't query more than 100 Dyna tables or 100 source tables. That's the properties. Because in Dyna tables, you can what you can do, right? You can put some joins and then put those results, materialized results in the Dyna table A, and then you can join both source tables and Dyna tables, and then you can and then it will give the materialized results. That materialized results will be stored in Dyna table B. That's what they are discussing here. Is I want to show now, guys, limitations. You can't query more than
100 tables, sir.
100
100
tables.
tables. 100 tables. Okay, we have limitations. Make it mute, guys. And then they are mentioning again same point here. 100 source tables also can't able to query, and then 100 dynamics also can't able to query. And then next point is you cannot able to truncate the dynamic table. You cannot able to truncate the data from the dynamic table. And then you can't able to create temporary dynamic table. You cannot create transient dynamic table, but you can't create temporary dynamic table. If session is lost, what will happen to temporary table? If session is lost, what will be a temporary table?
It will also get lost.
It will be dropped. It will be dropped. Okay, that's what is mentioning here is that transient tables. You can use the dynamic tables, but you can't create a temporary table in dynamic tables. Okay, and then I'm going to show some constructs. Okay, what are the constructs? We have some limitations. What are the limitations we have? Okay, yeah. First one I want to say is external functions. You can't use any external functions. You can't use any external functions. You can't use, like I can say, like user event functions. Okay, these functions you can't use. And then this Dyna tables only support on current user. Whoever using the Dyna table used to be the have the owner role with a special system user. Okay, you should have the account admin user or system user you should have. Okay, the other users cannot be able to use the Dyna tables to refresh. The external function you can't use, and then the Dyna table should have a one role. One role means account admin role you should have, or system user you can say. And then the sources that include you can't use data tables, iceberg tables, external tables, streams, and materialized views. You can't use this thing. We have limitations. You can't use data tables, iceberg. I'm going to discuss the later part. Iceberg tables, hoodie tables, external tables, streams, and materialized views. And then you can't able to create views on data tables or other unsupported objects. You can't able to create
Views, sir.
views on data tables, and then you can't use user different functions, UDF, user different transfer functions. You can't use this thing. You can't use unpivot. You can't use. These are the limitations we have in the dynamic tables. Okay. Now, yeah, and then see, these are the unsupported constructs, operator functions. I'm saying to you guys, we can't use pivot, union, minus, except, intersect. Okay, the union all. These are the lateral joins, and then we can use joins, outer joins where both sides are same table. Okay, these are the joints is not supported, and then in windowing functions, partition by is not supported. Okay, percent rank, dense rank, windows. See, what I'm saying is you can use the windowing functions, but the partition by is not supported. Okay, these are the limitations we have. Okay, whenever you are working with variables, you have to see all these limitations. Now I'm going to talk about the Dyna tables performance. Okay, how you can increase the Dyna table performance. This is just overview. Dyna tables mostly intentionally used for continuous data transformation. Continuous data transformation. You can able to easily create, you can use it, and then you can manage it. Okay, and then now I'm going to talk about the query performance in Dyna tables. Just click on the query performance. Just come here. Yeah, yeah. One second, guys. Query performance.
This conference will now be recorded.
Yeah, guys. I'll give a high level overview how to increase the dynamic query performance. Everyone knows we have the source data, right? Source data is generated ideally from the real world entities. It's connected from various systems, and then the data will be ingested through the ETL process. Okay, they're saying about how the source data has got generated, because it will be a file, it can be a table, it can be JSON or XML. Any system can be, it can be a real world entities. From there collecting the data, and then the second one, whenever get the source data, right, it will be ingested into the one of the Snowflake table. That data we can say is a raw data. Okay, after ingestion, the data is stored in Snowflake tables, and then from the raw data, you'll do the transformation, mostly used for analysis purpose. And then third one is modeled data. Model data is nothing but for analysis purpose, we'll use this model data. Every transformation, right? After performing a transformation, we have a set of models. Okay, after performing each bit transformation, you can say it's a model. In DBT, we'll say it's a model actually. And then mostly that model transform result, right? Mostly used for consumers for analysis purposes. For analysis purposes, I can put in a simple way. After performing the transform data, we can put in the dimension tables. From the dimension tables, what happens, right? The consumer will consume those data for analysis purposes. This is how the ETL pipeline will work. Now, um, now you might have a question in this, which part dynamic tables will occur. Now you guys have to say we are doing some ETL process where we can enhance this dynamic tables in source layer or raw layer or transform layer, or it's a modeled layer, data layer. I'm asking a question to you guys. I want to enhance this dynamic tables in which layer? In source data layer, I want to enhance, or raw data layer, or transform layer, or model data layer.
Transform
That
layer.
transform layer. In transform layer only, you have to enhance this dynamic tables. That's what it's saying. It is these actual flow of the ETL pipeline. Now, what happens, right? Mostly dynamic tables mostly used for continuous data transformations. Okay. Now we're going to talk about the materialization. Now, I already said to you, if anyone asks what is materialization, you have to say to that people, we're going to pre-compute from various tables. The results will be stored in a one table. That table is a materialized table. It will have your own physical location. They're mentioning it as materialized by pre-computing the results. Sendamal, I am stressing these words. If anyone asks, materialize means you have to say pre-computing results means you can able to extract the data from various tables by putting some joins or some kind of results, right? That kind of results will be stored in a one table for quick access. That is called materialized table. You won't store the actual raw data, whatever the Arif said, right? It's a snapshot. We won't store the snapshots. We will store the collection of results. It's a pre-computing collection of results from various tables, and then the results will be stored in the one table called materialized table for quick access. That materialized table will have a up-to-date information. Arif, got it?
Yes, sir.
Yeah, like you have to compute all the results from various tables, and then you have to put in your one separate location. That data should have a up-to-date information, should have it have a physical location. Okay, that is called materialized table, they will say. But here I am talking about only materialized. Materialized means pre-computing the results. Okay, and then now we're going to talk about the materialization boundary. There are two kinds of boundaries there. One is materialized boundary, another one is unmaterialized boundary. One is materialized boundary, another one is unmaterialized boundary. Materialized boundary means nothing but collection of results from the various tables, and then we are doing some transformations on that materialized one, and then giving the results. Unmaterialized means just what you are doing, right? You are not doing any kind of transformations, just you are putting the data as it is. Okay, on the materialized boundary is refers to the materialization boundary. The two things, materialized and unmaterialized part of transformation, nothing but materialized boundary. Now I'm going to discuss about lag or freshness. The freshness of data you provide. For example, if I give 5 minutes, right, every 5 minutes will keep on refresh. I will have the up-to-date information. Up-to-date information. Okay, if you are giving the lag as 10 days, what will happen, right? The data will not be up to date. Like we have the 10 days old data. Okay, that's what in the metallization boundary, what you have to do, you have to provide the lag of freshness. If you are mentioning like lower lag, right, what happens, you have the up-to-date information. Second one is response time. Response time means, for example, freshness is always at least as long as the response time of your queries. Okay, now what happens, right? Whenever you are providing the lag, right, or 5 minutes, what happens in between that lag period? What happens? Your query should run, and then it has to generate the results, and then it has to persist in the dynamic tables. Okay, and then if you are materializing your pipeline, right, that's going to reduce your response time. That's going to reduce your response time. And then third one, I'm going to discuss about cost. Okay, third one, cost depends on three factors. One is the cost of materialization, and then cost of computing the unmaterialized transformation, because you are not doing any kind of things over there, just you're going to load the data as it is. That's going to reduce the cost. And then third one is cost of storage. Okay, you can include both raw data and materialized data. Now they're saying how to materialize it. What they are doing is, if you want to materialize your data, right, what you have to do is you have to get dynamic tables. That dynamic tables, what happens, right, as per the lag time, it will keep on refresh your data, and then as per the query, it will do all transformation. The transformation results will be stored in the your dynamic table. This is how you can able to materialize it. Next one is refresh performance. Okay, I'm going to give a high level overview how to improve refresh performance. One is workload. Okay, tune your workload by refining your queries and the characteristics of your data. Second one is refresh mode. Adjust your refresh mode to match your workloads. It can be full refresh or incremental refresh, and then refresh your schedule cost. Fourth one is the warehouse consideration. If you use big warehouse, right, what happens? The computing will be more, and then it will try to extract the increment records very faster. In this way, can able to achieve it. Okay. Now just go to the workload. How workload affects the dynamic table performance? So look at here. I'm going to discuss about the 4 points. Okay, workload, refresh mode, refresh schedule cost, and warehouse considerations. First one is workload. what are the workload affects the dynamic performance? Okay, if you are using millions of records, if you are using millions of records, what happens? If you are going for a full refresh, it has to take the full data and then put into the dynamic tables. In order to reduce the cost and improve the performance, these are the steps you have to follow. What is the first step? What is the first step?
Adding filters to reduce the amount of data being
Reduce amount of data we scan because I need only today data where timestamp equal to current timestamp. If I give like this, what will happen? It won't extract the full data. Today data alone will extract. We can reduce the amount of data being scanned. That's why the saying is whenever using data tables in the SQL query, try to add some filters. If you're using filters, right, the filters will filter that part of data. You will get only less amount of data. Second one is Sendamal. What second point? What second point? It's very simple. Second point, Sendamal. Anyone?
Eliminating duplicates earlier in the pipeline and
Pipeline subsequently avoiding uses of distinct. Okay.
distinct.
Okay. See what they're saying is in the earlier pipeline itself, what you can do, right? You can eliminate duplicates. Once in dynamic tables, most people what they will do, right? They will try to use a distinct things. Okay. After transformation, they try to use a distinct. Before itself, you have to use a distinct and then filter the duplicates and then that filter records you give to dynamic tables. Satish got it? Sandamal, what I'm suggesting is first apply filters. You can reduce the amount of data. Second thing is Anand, you can you can remove the duplicates. Okay.
Yes, sir.
Subsequently, no need of using any distinct keyword in the dynamic tables. Okay, if you are using removing duplicates, right, what happens? You can reduce the amount of data. Third point, anyone?
reducing the use of null and
Null, because
ensuring that
yeah, what they're saying is just filter the null values. Okay, don't allow the null values. Reduce use of null, and you ensure a referential integrity in your source data so that you can replace outer joins with inner joins. What they're saying is you can able to reduce use of null values. Just you have to filter it, and then the referential integrity. Okay, what happens, right? One table should be performed with another table as a join key. Okay, like if you do what happens, right, you can merge those two tables single table and then you can able to use the dynamic tables. That's what the saying here is. They're saying is don't use outer joins. If you use outer joins, right, more columns will be occur over there and then use some inner joins to extract some specific columns. One second, guys.
This conference will now be recorded.
Yeah, what I'm saying is don't use any outer joins. Okay, if you are using outer joins, right, what will happen? What happens, right? It will take all the records from left and right. Okay, that's going to add more complexity. Okay, and then fourth one is avoid materializing large columns that are read infrequently. For example, if you are using some columns that are read infrequently, right, don't materialize those large columns. Okay, which are columns they are used infrequently. These are the considerations you have to keep in mind not improve or choosing your workloads. If you are using all these things, right, you can able to increase your dynamic performance. Okay, if you are not considering these factors, what will happen? The dynamic tail performance will not be improved. You have to keep in everything in mind. Next one is locality.
This conference will now be recorded.
Sir, mic is off, I think.
Yeah. Hello. Yeah. I will discuss about the locality part. Now, what is happening right in the locality part? Just now to improve good performance, the data of your query should be very close together. Okay. Mostly in the tables, what we'll do, right? We'll use a clustered by key. Using clustered by key, you can cluster into various groups. Okay. Now, whenever you are querying the data should reside very close to the cluster. Then only you will get the results very faster. That's nothing but the locality. Okay. Whenever you are choosing the layout, right, for data tables, the data of your query should be very close together. If you are clustering to various clusters, because we will use micro partitions in the Snowflake tables, after micro partitions, we'll use cluster by key. Based on the key, it will be sitting in the various clusters. If it is if your data is if the data is near to your cluster, then you'll get the results very faster. In this way, you can able to improve it. Now, second one is refresh mode. How refresh mode affects dynamic table performance. Okay, now you have to, two things you have to keep in mind. One is full refresh mode performance, another one is incremental refresh mode performance. I already discussed with you guys, keep the lag time more. Okay, if you are subsequently refreshing the source table, right, what happens, it's going to additionally incur the cost. That should not happen. And then third one is warehouse considerations. If you are using dynamic tables, you have to use the big warehouses. If you are choose small warehouse, what will happen is the memory will be very limited in the small warehouses. Okay, what happens? First, we will discuss about the memory part. If a query requires more memory than a warehouse, in a warehouse I have 8 GB RAM, but query requires 10 GB RAM. What happens? The intermediate data will spill into the local storage. Now everything will be processed only through memory only. Whatever the data transfer is doing, right? Everything processed through memory only. That's why it's very faster. Now what happens, right? I have 8 GB of RAM, but my query requires around 12 GB of RAM. What happens, right? It can't keep that much data in memory. The remaining data will be spilled over to
Local storage.
local storage. At the time, what happens, right? It will reduce your performance. What you have to do, you have to choose here one X large warehouses. The X large warehouses will have a more memory, and then what happens, right? The spilling won't occur because the entire data will keep in memory. What are the query executing, right? It will have that much memory. Okay, that you can able to prevent the spilling and then significantly speeding up the query. Second one is parallelism. You can run a query very faster. For example, you are doing so much transformation, filter transformation, aggregation transformation. All things will be actually in a parallel way. If you are going for a very large warehouses, if you are offering parallelism, okay, what happens, right? It will reduce your query time without raising cost. Okay, the query time will be very less. So that's what I'm saying is moving from small to medium size warehouse typically doubles the cost and half the runtime. If you want to reduce the time, just go from small to medium warehouse. If medium is very slow, go to large warehouses. It's what happens, right? The cost will be double, but you can increase your performance. I'm not talking about cost part. I'm talking about
Performance. Performance.
performance.
Performance part.
Don't think about the cost part as of now. Okay, just think about the performance part. Let's go parallelism and then increase the memory. If memory is very limited, what happens? Data spill will happen to the
Local
local
storage.
storage. Just I'll give you example to you guys. For example, I can say like I can take only like one packet of biryani, but I have 5 packets of biryani. How can I able to take? I can keep in my fridge or somewhere, right? The remaining 4 packets I can keep in fridge. After consuming the 1 packet of biryani, I can able to consume the remaining 4 packets. The same thing, if the memory is not sufficient, it's going to spill the data, whatever it's not able to consume, right? You'll put in the local storage. And then parallelism also you can able to do. If you are doing parallelism, cost will be more, but query running time will be less. These are the various considerations you have to keep in mind for creating your dynamic tables. Now I going to give you a quick demo. Already I did for these 2 sessions, right? How to do the change the capture using dynamic tables. I'm going to follow this example right now. I'm going to create this table. It's the employer R table. As it is, I'm going to do. Whenever you're copying from the sites, just put in notepad and then place it. Now go to your worksheets. I'm doing this for Arif, okay, not for anybody else because he is absent on these 2 sessions, right? Just Arif, what you have to do? You have to create a database. Just keep it as data transformations. Database name is create database if not exist. Just create a database and create your schema now. Now create a schema. Create schema. It's going to be a dynamic underscore schema. Create a schema. Now you can see it was choose the database name is data underscore tx. Schema is dynamic underscore schema. Now everything good. Now Arif, this is my source table. This is my source table, or you can say it's a raw table also. Raw table or staging table, anything it can be. Okay. Oh my god. I think 1 second, guys. Yeah. Or if what it is, it's a raw table. Now in a raw table, I'm going to insert how many records? Marif,
3 records, sir.
3 records. Or if already we did this use case, for you only we doing this use case again. Yeah. Now 3 records got inserted. You can see the raw table. Select star from employee underscore raw. Yeah, now you can see, right? ID, name, and salary. These are the 3 records we have. Now, I'm going to create a dynamic table. Create or replace dynamic table. This is syntax actually. Create or replace dynamic table. Give the table name, and then target lag you have to give 1 minute. Every 1 minute, it will keep the refreshing. It will be refreshing the source tables. It will be refreshing the source tables, and then give the warehouse name. Which warehouse you're going to use? I'm going to use computer underscore wh, and give as, and then provide your transformation logics here. Provide your transformation logics here. Just copy. This is how you can create a table. Now I'm going to write one transformation. Or if where what is that once again, guys, where salary greater than 30,000. Now what transformation it is?
Filter, sir.
Filter transformation. It's a filter, 30,000, right? Just now going to get dynamic tables. Or if dynamic table name is, dynamic table name is, what is the dynamic table name? Or if dynamic table name is employees. Now what happened, guys? See, that's what I'm saying. While copying, right, from the size, you'll get some this kind of issues. Just put everything in, put everything in
Notepad plus.
Notepad, not Notepad plus plus, Notepad, and then create dynamic tables. Again, some issue. See, you can remove this one. Okay, the syntax same. Again, I'm getting some issues, guys. One minute, guys. Just I will remove all these things. Yeah, and then I'll remove this one as well. Put in single line because while copying, right, some special characters also got copied. Yeah, now I think it will run. Yeah, now the dynamic table got created. Make it mute. Now the dynamic table got created. Go to our database tx, and then where it is dynamic schema, and then table is dynamic tables. You can see dynamic table is employees. Here I'm not using any cluster by key. Okay, just go definitions. You can see the command, what a command I used, right, for creating the, yeah, for create, so it's showing some information schema, right? Sorry guys, I want to show the employees. You can see the command. Okay, create a replace dynamic table, and then what transformation I used, right? I can able to see everything here. Good. Now what I want to do is I going to insert few records in my which table, or if in my raw layer, in my raw layer. Before inserting all these things, I want to say a few more things to you guys. Or if just query this table, select star from employees table. Now in the employee raw table, how many records are there? Or if employee raw table, three records are there. Though using dynamic table, what happens, right? It will perform the continuous data transformation. Now in employees table, how many records will be there? In the dynamic table employees, how many records will be there? You have to say. Because it's a continuous data transformation. Only two records will be there because I'm giving salary greater than
30,000.
not 3,000, 30,000. Okay. Now we'll get only two records because it's a continuous data transformation. Now what I'm doing is select star from employees. You can see only two records. You can see two records, right? 102, 103. Chris and Bruce. Now what I'm going to do is I'm going to just going to do the update. Insert, update, delete in the which table? Which table?
The employees raw table, sir.
Raw table. Okay, I'm going to update, do the insert operation, update operation, delete operation in the raw table. Now just insert, update, delete. Now three things happen. Now if you go and see this employees table, right, you won't see the data. You have to wait for. Have to wait for
1 minute, sir.
1 minute. Then only the refresh will happen. You have to wait for at least 1 minute. 1 minute means 60 seconds. don't know why it's not updating. I think it's not cross 60 seconds, I guess.
Sir, it got updated, sir. I'm not deleted.
Yeah, 104 new record came, right? Yeah, 104 Clark came. Okay, see records. Yeah, 104 Clark came. It's updated. 104 Clark is updated. And then set salary equal to 45,000, where ID equal 103. That thing also got updated. And then I'm deleting the 102 ID. Arif got it?
Yes, sir. Yes, sir.
Yeah, this is how data table works. It's a continuous data loading. If you want to go into deep dive, just refer the recording 1 and 2. We have created 3 chain data tables on the day. 3 chain data tables: data table 1, data table 2, data table 3 we did. Okay, just go and refer 3 sessions. Just what you have to do is, it's a 1 chain data table. Now, these things we already discussed. Okay, or if you want to see the data tables, you can use this command. What command? Show
Show
dynamic
dynamic
tables.
table.
Dynamic tables. You can see like there's no. I'm not using a cluster by key. Control is 2. I am the owner. Owner only can use perform the dynamic tables. The other user cannot able to perform the dynamic tables. Target lag is 1 minute. Refresh mode, incremental mode, because dynamic tables default will support incremental mode only. Because every company will follow the incremental approach. Okay. Barrows are using computer underscore WH. And then you can see automatic clustering I made it off. Scheduling state is very active. My dynamic tables is active, and then I'm not doing any cloning. I'm not doing any replica. Okay, this is the thing I'm can able to show in the show dynamic tables. Next one I want to show is this one is very simple, guy. If you want to see the information, right, you can use the describe dynamic table, and then you can provide dynamic table name, employer raw. Sorry, it's not dynamic table, right? Guys, I made a blunder mistake. I want to give the dynamic table name. Dynamic table name is
Like,
employees, not employer raw. Just give the describe dynamic table employees. You can see, right, what's the column name, what's the type, and what is the kind. Everything can see here. And then next one is, if you want to suspend, alter dynamic table name suspend. You can do. We can manually make the dynamic table suspended. If it is suspended, no additional cost will be incurred, but storage cost will be involved, because dynamic table store the material results in the dynamic table. Okay, you can able to resume it. These things we already seen it. Okay, now these things also we already seen in the previous class. Dynamic table refresh history, it's one of the important table. It will be average information schema. If any error encountered for continuously 5 times, that error information will be captured in this refresh history table. Okay, that's why I made error only equal to true. This thing we've seen. Now for RF, I'll show this thing. How to monitor the dynamic tables. What you have to do, just go to data, click on databases, go to our databases, go to schema, go to our schema, dynamic schema, go to dynamic tables. You can able to see like two tables will be there, tables and dynamic tables will be there. Go to dynamic tables and then click on this one. You can able to monitor. First, you can able to see the table details. What are the tables you created, right? Dynamic tables you can able to see, and you can able to see the column names as well. These are the columns I have created. Joins also you can do. You can join 2 raw tables or 3 raw tables, and then you can do joins, and you can do the material results into the dynamic tables. but outer join you can't use. The remaining joins you can, left join you can use. And data preview, you can see the preview of your data tables, and then you can see the graph. It's a DAG. DAG is nothing but direct acyclic graph. This is my raw layer. Or if this is my raw layer, this is my dynamic tables. Like this, you can create n number of chains. Or if got it, you can create n number of chains. Okay, for dynamic tables. I'll do one thing for you. I'll create one more chain to you. Then Arif can able to understand. Just you go to the projects again. Go to the this worksheet. Again come here. Now Arif will say, I want to create one more dynamic table. I want to create one more dynamic table. Dynamic table name is employees underscore duplicate. Arif, just make the name as duplicate.
Underscore duplicate.
Yeah, then make the target time as 3 minutes because it should refresh 1 minute. It should refresh 3 minutes. Okay, like should give a higher lag for this. Now, what I'm going to do is I'm going to filter. Let's see the results where ID equal to 103. Okay, we'll make where ID greater than 102 or 103. Okay, we'll make it 102. Now I'm creating one more dynamic table. Yeah, now you can see the results. Now how many records should come? Greater than 1 or 2 is that right? Like this, you can create n number of chain dynamic tables, but that is a limit. Only 100 dynamic tables you can able to create. Okay, not more than 100. Sorry. Like 4,000 dynamic tables you can able to create. I had a blunder mistake. 4,000 dynamic tables you can able to create. Yeah. Now, for this dynamic table, you can see the filtered transformation results. Guys, I made a mistake again. I want to make it 103 again. Then only I can see only one record. Again, it will recreate. Now it's recreated. Now you can see. Okay, able to see right? I filtering greater than 103. I got only one record. Now just go and look at the data. Database and go to transaction schema. Sorry, schema, dynamic schema, and then go dynamic tables. Now I will show the DAG for you. DAG means direct acyclic graph. I think it's not refresh, guys. 1 minute. Just refresh it. I made a blunder mistake. No one said to me. No one said to me. I made a blunder mistake. Sandoval, what mistake I did? What mistake I did? While create editable duplicate, the mistake I did is I want to give the dynamic table 1 as input, right? Or if don't make the mistake again. Okay, if you are creating a chain dynamic tables, you have to give the dynamic table 1 as the dynamic table 2, because in this dynamic table 1 you have 2 records, right? Select star from, sorry guys, select star from employees. Now how many records are there? How many records are there? Employees. 2 records are there. 2 records there, right? It's a dynamic table 1. Sendamal, it's a dynamic table
One, sir.
dynamic 1. Now we have to give this dynamic table to dynamic table 2. You have to provide it. Okay, dynamic table 2 is name is 2 name is employee underscore duplicates. Now just create dynamic table 2. If you are creating a chain dynamic table, you have to create like this. Now good. Now just go and query this table. You will have only one record. Got only one record, right? Now again you can go database and then go to transactions. Database schemas, dynamic schema. Go dynamic tables and go and see the another one got created. Okay, just click on this. Just go and see the graph. Can see the graph, right?
Yes, sir.
Yes, sir.
Now the dynamic table one got succeeded. Okay, after succeeded, this transform data is moving to dynamic table 2. It also got succeeded. Like this, you can create a number of chains. Okay, no need of any like scheduling anything. Automatically, once the delta comes in, increment records comes in, it will do the transformation. Again, it will do the transformation. Like this, you can do in dynamic tables. That's the power of dynamic tables. Or if you have seen this dynamic tables in any databases, have you seen these dynamic tables in any data warehouses apart from Snowflake? Okay, this is a concept introduced in Snowflake as well as in Databricks. Okay, hoodie tables, iceberg tables, external tables. In external tables, you can do partition by, cluster by. All these features are available in Databricks as well. Right? These are the properties. If you want to look at the table details, you can be able to see. Just go to the dynamic employees and then you can see the graph. Okay, you can able to see only one graph, because if you look at the second one, right, you can see the lineage. You can see the lineage. This dynamic table 2 depends on dynamic table 2 depends on
Dynamic table
1. Dynamic table 1 depends on
raw source.
raw source. This is how the dynamic table works. Okay. Now the last feature I want to show, this is how you can do the monitoring. Okay, I want to show the monitoring as well. If you want to see the monitoring, click on the refresh history. Now, in the meantime, how many refreshes happen?
Sir, 6 refreshes.
6 refreshes happen because they given like 1 minute lag time, right? Just keep on refreshing, right? You can see like how many records were changed. 2 records were changed, 1 record was changed. Okay, like this you can see like a monitoring activity you can do. And then if you want to see the query profile, click on this. You can see the query profile result as well. You can see, right? This many operations were happening in the backend. Okay, like all kind of filtering, all kind of projections, filtering joints, these kind of things, table scan is happening. This kind of things we can able to see in the query profile. Let's see who are doing the optimization, performance tuning. They will get all the statistics, how much bytes scan. They'll click on this and they'll get information. Okay, what are the filter it scanned? Okay, employee duplicates, and then I said, right, each that will have the metadata row ID. I said or not? While
Yes, sir.
taking theory, I said each that will have a metadata row ID. Okay, it will have a row identifier that will take more storage space. Because of that, they will charge additional incur cost. Okay, like this, so much things we can able to see. Okay, like insert operation you are doing means you can see some insert action is happened in the metadata action. Good. And then you can see the refreshes. The warehouse is using compute underscore wh. Now what happened? 7th refreshes happened. Okay, and then you can see like how much time it took. 1 minute 49 seconds for the 7th refresh. Like this, you can see all the statistics here itself. Now this is how you can do the monitoring activity. Mostly you won't have the access for this. The admin have the access for this to do the monitoring activities. Now the last one I'm going to discuss, this part is not covered on the day. That is nothing but the monitoring dynamic tables graph. Okay, you guys already know dynamic table 2 is built on dynamic table 1. Dynamic table 1 is built on base table. Every dynamic table have a dependency. Okay, you can create a chain of dynamic tables. One dynamic table depend on another dynamic table, and then dynamic table 1 is depend on base table. This is how this dynamic table chain works. Now we're going to see the graph history, guys. I want to show the graph history. The function they given us dynamic table graph history. From the information schema, you can able to use this function. The information schema is going to the metadata of the table. Metadata. It contains all the database objects, informations, tables, views, materialized views, and then dynamic tables. All kind of metadata information will be available in the information schema. Just I going to run this one. We're going to see the graph history, because I already said one dynamic table is depend on one dynamic table depend on another dynamic table. Okay, guys, do one thing. Just again go to the projects and then go to title. Just execute this command. That's it. Select star from syntax are exported, because see here while copying, right, this kind of issues will come. Yeah, again some issue is select star from table. Let's see, guys, what's the issue. It's showing unexpected table. Select star from table. They're asking to provide table name, right? One second, guys. Dynamic table provides history dynamic table. It provides property depends on other tables and dynamic properties. Okay, I'll do one thing, guys. Select star from table, information schema from dynamic table graph history. Okay, I want to see all the DAX. Yeah. No, some mistake is there. Okay, I think while copying, right, it's showing some green red color. Just make it a single line. Yeah, just run it. Yeah, it's giving the information. See, while copying, what happened, right? This black color is there, right? It will take some values, okay, but you can't able to see. It will take some special characters. You can't able to see. That's why I'm making single line and then running it. Now you can see we have two dynamic tables. The scheme also same. Data name also same, and then we have the qualified names, and then you can able to see what is the input. It's a table actually. The name is going to be a database name, schema name, table name, and then the target lag type is user defined. I get 160 seconds and 180 seconds. Okay, and then I see it's valid from valid to that's no date. Okay, scheduling state is very active and alter trigger. Okay, because I can able to alter this dynamic table. That's why I make us create dynamic table. So alter trigger is there. Okay, this is how you can see the graphs. Okay, this is how you can able to see the graph. That's the use of dynamic table graph history. It's going to provide the history of each dynamic table, its properties and dependencies and other and dynamic tables. Okay, it's going to give the properties for you guys. Now next one is using Snowsight. You can see all the DAX. This thing I shown to you. You can see the DAX and then you can see the query profile for optimizing your dynamic tables. If your dynamic table taking more time to refresh, what you can do, right? You can apply some filters. You can remove the duplicates before itself. while applying the dynamic tables. Okay, as well as you can increase your computing power using the computer warehouse to X large. Okay, these are the various performance tunings you can do in order to improve your query performance as well as dynamic table performance as well. Guys, I'm going to close session right now.